All right, so we have, I'm glad that somebody already asked me about the end of the quarter, because if you're a good student, you want your grade to reflect how well you've been working, how hard you've been working. And you also have to know the rules of the game. And one of the games that we play is that we have these quarters. Now, quarters, they have a report card grade that comes from the first quarter, second quarter, third, and fourth. And so we have to know that that's a game that they play. I call it a game, but it's just rules. It's just like when I play soccer, we have rules, don't we? And that's the rule. You don't say, hey, the ball went over the line. Why do you have to stop play? Well, that's the rule. It goes out of bounds. You got to have a throw in, don't you? You don't ask why. You say, well, that's the rule. So a good student knows the rules also. And so we have a week from Friday. A week from Friday is actually a half day. You get off at 11:30, and that's the official end of the first quarter. Now, it's possible, not certain, but it's possible that a teacher could give you, I'm going to try to give a test next week to you. It probably will be on Thursday, so a week from tomorrow. But a lot of other teachers may be giving tests also. If they didn't give it this week, they'll probably give it next week. So I just want to make sure you understand that. So you might have to work hard, between this week. There's not much of this week left, is there? So you work hard this week, work hard next week, and then you get to start all over again. And you get a second quarter. Got that? And then you try to work really hard on the second quarter. And then they have these things called exams, and those are in January. And they are based on the whole semester. And again, those are kind of hard, but if you have your old tests and stuff, you should be in good shape there. And then you start again. You start all over again. Anyway, at the end of the year, they'll take the first semester and the second semester, add them together, give the average, and that's what the only grade will show up on your transcript. So if you get ready to go to college as a junior, they'll say, send my transcript to Chapel Hill. They'll say, ninth grade, what did you take? What was your final grade? 10th grade, little box, what did you take? What was your final grade? You get that? So I know your report cards are important to your parents, but ultimately the big grade is the one by the end of the year. So if you didn't quite make an A this quarter, you say, but I can work harder and I'll have an A average. See that? And you know what's really hard? Is to maintain an A all year. That's what's hard. It's like, what if you have a really good basketball team and they win the first 5 games? You know what's really hard? To win the next 5. And then what if they're 10-0? You know what's really hard? To win the next 5. And that's what happens. And some of your championship teams, they have to be able to go the whole season. They can't just be good at the beginning of the season, can they? And that is what's hard. You should applaud people who get A's in classes or even high B's, because they've had to do that the whole year like that. So as far as your class, we should be ready to have a test a week from tomorrow on this chapter. And we'd probably be, I would say maybe by Wednesday, we would be reviewing. I'm hoping we're going to review it by Wednesday. I hope that works out. All right, so is everybody okay on that? So if I look at your grades, for example, now you have a homework. What's your homework assignment? That's going to be due next week also at the end of the week. So what is that? Remember what that is? It's at the back of the chapter. Remember that? And you do the odd questions. Remember, you only do the odd questions, don't you? And if, let's say, number 11 has 8 parts to it, how many do you do? You only do 2, right? So anyway, when you get done, there'll probably be around 60 answers somewhere on that sheet. But some of them are pretty fast. Some of them will say, look at this number here. What would the exponent be for that if you put it in scientific notation? Here, do this right here. See if you can see how easy this is, right? Here's one of the typical questions you might have on your homework. Hey, Luke, can you close that door for me, please? Here's a typical question you might find on your homework. What if it says, put this number into scientific notation? And we even had a quiz on that, didn't we? So what do you think? That would be a typical homework question. So who wants to do that one? Charlotte, you want to do it?
3.4 times 10.
And we can't lose numbers. So, okay, go ahead. Is it positive third or negative third? Yeah, because that's a big number, isn't it? And that's a big number, isn't it? So that would be one of your homework questions. Hey, I can do that pretty fast. They have one that talks about how many significant figures in a measurement. We're going to do that today. That's today's lesson. And so you'll be able to do those. So I wouldn't wait too long. Remember I said every other day, if you spend 15 minutes with chemistry, you can probably keep up. Some of you haven't spent any time in a week, right? That means you have an hour. You owe me an hour. So you said, okay, when's that going to be? Tonight for an hour? Is it going to be tonight? Tomorrow night? So anyway, you want to keep up. You don't want to wait till next Tuesday or Wednesday to start your homework. Yes?
What do you do again?
What is it?
What does it do again?
It's always due the day of the test. So right now our test is a week from Thursday. So you have probably a total of 10 days to do these. And so now some of them you can't do because I haven't taught the lesson yet, but I'm going to. But I'll be done with the lessons by Tuesday. Yeah. All right, so if I could have your attention, I'd like to start today's lesson, and let's do a review. You could, some of you, can you guys put your head up? Put your head up. There you go. I know you're tired. I know you took a PSAT day, didn't you? Okay, you got one more day for me. If you do happen to go to, like next year, you'll take physics. They'll have a unit on measurement. If you go to college and you said, I need to take chemistry, or I need to take physics, or a math-based science, they'll have a unit called measurement, just like you're doing right now. And if you go work somewhere where it's a science-based company, it's kind of have something to do with measurement, isn't it? And so it's not like a small thing. It's like a big thing in science. So what happened is I drew a line, and if you remember, I measured it, okay? And I measured it. And when you measure it, what are you supposed to do? You're supposed to write down every number you're certain about because you have lines. And then how many numbers do you have to guess on because you don't have lines? Only one. So when I put this ruler down, we said, what's the measurement on this line? You said it was what? 1, maybe 1.2, maybe 1.3. And what are these units called? What is this called right here? It's not a meter. What is it? Not centa, decimeter. It's a tenth of a meter, isn't it? Okay, then I gave you, so anyway, notice I only had 2 significant figures. What's next? What if I give you a better ruler? Look right here. What if I give you a better ruler? Now what? Now you might say, well, I thought it was like maybe a little over 13, a tiny bit, maybe. And I know it's 13, but maybe it's 13.1. Well, notice what, and these are in centimeters, but look what happened. With a better ruler, I went from 2 significant figures to 3. Can I ask you a question? Which one do you trust more? Which one do you trust is more accurate?
Second one.
The second one. Let's try again with a nice ruler. This is a nicer ruler. And when I did that, we got 13.13. We had to estimate here. Now, what you're not going to like, and I mentioned this before, you don't like the idea that measured numbers don't follow exactly the same rules that they do in math class. Math class did not use measured number, do they? There's no error. In science, when is 5 centimeters not necessarily 5 centimeters? Who knows that? Rachel, what do you think? When is 5 centimeters not necessarily 5 centimeters? I'll give you another clue. When's 1.2 decimeters not necessarily 1.2 decimeters? Okay, what do you think? Anybody? Raise your hand. When is 5 centimeters not necessarily 5 centimeters? Yes? When what? When you measure it. Yes. When you measure it. Because if I give you this ruler, you're going to give me a measurement, aren't you? What if I give you this ruler? It might not be 5, right? What if I give you this one? So anyway, a measured numbers, we have to have these things called significant figures. Now, what if you thought that line was right on 13, but I'm using this ruler? What would you be forced to write? If you knew, With this ruler here, what would you be forced to write if you thought it was right on the 13?
13.0.
Now, if you say that, if you say 13.0, you're telling me that you had lines for the tens place and the ones place. You're saying you did not have lines for tenths because you're telling me you guessed it. But look at the ruler. Do you have lines for tenths place?
Yes.
So in a way, see, that's a lie in the world of science. That would be a lie to say 13.0. So we had to do what? With this ruler, it has to say 13.00 because you don't start guessing on this ruler till you get to hundredths place, do you? And so I understand the math teacher will never tell you that there's something different between these numbers. They'll say there's no difference because what world do they live? They live in a world of not measured numbers, but theoretical numbers. They're perfect, aren't they? There's no error. You don't measure them. Okay. Now the reason I lead you into here is that the next part, and this is in a way, these are some of the easier questions on the test. I used to work in public school for about 29 years before I started teaching here. I've been here about 17 years, and but anyway, I remember when I first started teaching chemistry, other people had already been teaching chemistry, and I remember when I got to, I was, I said, well, I have never taught chemistry, and I started that about 30 years ago, and so some of the teachers were saying, oh, I always hate it when I teach this lesson right here. Because I didn't know exactly what they meant, why they didn't like it, because most books have 4, 5, 6, sometimes 7 rules about significant digits. And the teacher was saying, I worked so hard to get them to understand those rules, and then to give them a quiz on it, they act like they didn't learn anything. Well, number one, I'll tell you, I don't teach that way anymore. After the first year, I noticed that doesn't work for me. And so, number one, a lot of the kids in the public school, and it could be in other private schools, when they're taught about significant digits, number one, many times the teacher doesn't tell them where they come from. Where do significant numbers come from?
Your guess.
From what?
Your guess.
The guess? That's only part of the significant digit, isn't it? Isn't that the last digit
Yeah.
of the significant figures? So where do they come from? Look right here.
The ruler.
Or what if I don't use a ruler?
The line, the measurement.
Right. You see that? First of all, I don't think they understood where they came from. And so the teacher was playing a game with them. They said, hey, see these rules? Learn all these rules and tell me how many significant figures are in that thing. Well, number one, it was kind of like a game. They didn't even know what we were doing. They just said, let's play the game. Here's another thing I didn't like, and I changed the way I taught. They used to have 5 or 6 rules on how do you know if a number is a significant digit or not. And then I figured out, I know why students have trouble with it, because some of the rules tell you why you are significant, and 3 other rules tell you why you're not. Some other numbers are not. Can I give you a hint? What if I only teach you the rules that say you're in the club? If I say these are the rules that tell you you are significant, I don't want to teach the rest of them. I crossed them out, didn't I? You say, but if you don't teach those, I won't understand. That's not true. What if I only tell you the rules that say this? If you're this, or this, you are a significant digit. Then why do I need to teach the rest of them? Why do I need to teach you a rule that says this one's not because of blah, 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 blah? And this has worked really well for me. I've had kids go back from college, and they said, well, we have significant figures, and I was just like that for me. And everybody else hated it. Now, it's not about me anyway. It's just that I used to be where you were, and there were a lot of things I just did because the teacher told me to do. But I didn't understand them. So, can we do this? Can I get your attention? I know your brain's not exactly where I'd like it to be because of PSAT today, but can I show you an easy way to do this? And when you have this on the test, you'll say, I'll eat that up all day. I'll eat, give me 5 of those quick. Give me 10 of them. I'll get every one of them right. Are you ready? All right, here we go. The only thing I got this out of a book. The only thing I didn't like is they didn't put units after it, so I'll just make up some units, grams, centimeters. So can you pretend that these all have like units after them? Can you just pretend that? Okay. So I think and see, even the person who wrote this thing, they were playing a game. And All right, so let's go. I'm going to show you how to do this, right? Now, you might even ask yourself, why would I need to learn this? Well, here's what happens. What if you are reading about somebody else's experiment in science, and they say something like this? What if they say, I measured something that was 5 centimeters long? What goes on in your mind if you're a real scientist? What kind of ruler was that? What do you think? Good one? Expensive? That was a bad one. How many sig figs? One. You know what the ruler looked like? Here's what the ruler looked like. 0, 10. 5? That's what you tell me. See that? Now watch. What if you read another scientist report and they get this? Now what are you thinking? That's a better instrument, isn't it? You didn't guess until when? I know exactly what your ruler looked like. I know exactly what it looked like. It had lines for ones. It had lines for tenths. You just didn't have lines for hundredths place. Now that you understand the game, the rules, let me show you how easy it is to figure out how many sig figs a measurement had, and you weren't there. You're looking at someone else's measurement. You weren't even there, and you'll know what their instrument looked like. Are you ready? Rule number 1. In a measured number, if you're a number that's not 0, if you're 1, 2, 3, 4, 5, 6, 7, 8, 9, you're in the club. You're called a significant digit. I'm going to show you how much. Where's your paper? Okay. So what we're going to do is, I'm going to do all 10 of these with rule number 1. I'm not going to do number 1 and finish it. I'm going to do rule number 1 for all of them. Put a single line underneath that too and say, rule number 1 says you are significant. How about you? Oh yeah, you're not a 0. That's right. Yeah, that's right. Yeah, you're in. Oh, look at all the ones that are not zeros. Man, oh man. Now, can I ask you a question? Be honest with me. Is there anybody in this room that does not understand rule number 1? That is about as easy as it gets, isn't it? If you're not a 0, you are a significant digit. All right, how about rule number 2? Rule number 2, ready? What if you're a 0 that's trapped in between 2 significant digits? Now, if you become a famous scientist, don't say this in front of a camera, in front of the whole world. I made this up. I call it the Oreo cookie rule. Now, the Oreo cookie rule, you know, they got a wafer, and you got a wafer, right? Well, what's in between?
Cream.
All right, if you get a 0 trapped between 2 wafers, you're in. You're in the Oreo. Okay, so I want you to find me a trapped 0. Find me an Oreo 0, and there's no trapped 0 here because there's only one wafer. There's only one part of the cookie. Now look right here. How about here? Any Oreo 0s here?
No.
No. How about here?
Yeah.
Whoa.
Cream.
Now I'm going to put 2 lines underneath there because that reminds me of rule number 2. And I'll never ask you what rule these are. I'll never ask you that. You get that? Now, is there an Oreo cookie on number 4?
Yep.
Yeah,
Look at that 0. Look at that guy. Oh, man. How about these?
No.
No, there's only one cookie. There's only one wafer, isn't there?
Yep.
There's no Oreo. How about here? No. How about here?
Ice cream.
Okay, I'll put 2 here. How about here? There's only one wafer. How about here? Uh-oh.
Oh.
There you are. Oh, look at here.
Oh, shoot.
Oh,
Triple stuffed Oreos.
Oh.
Now let's be honest with me, okay? Is there anybody in here that doesn't understand rule number 2? You said, well, this is much easier than I thought. You told me back in the public school that people hated this lesson. I've made it so you don't hate it. I'm going to try to. Now, rule number 3 is the only one you got to pay attention, okay? I have one of the 3 rules I need you to pay attention to. Are you ready? All right. If you are a trailing 0, now, what's the definition of trailing? Trailing means you trail a significant digit. Okay, trailing zeros count if. If what? Well, read it. First of all, you have to be a trailing 0. That means you have to come after a sig fig. And then you don't always count. You only count if what?
A decimal.
Okay, so let's watch. Do you see any trailing zeros? You see anything that comes after the 2? No. Then these are not going to count. I'm not going to teach you the rule that tells you why they don't count. I'm going to teach you the 3 that say you do count. You're not. You're done. I'm done with this one, aren't I? This one's done. There are no trailing zeros. I've already done rule 1, 2, and 3. So what's the total number of significant figures right here?
1.
Okay, do the next one. Does this have a trailing 0?
Yeah.
Yeah.
Does that come after the 2?
Yeah.
Now, it only counts if there's a decimal. Is there a decimal somewhere?
Yep.
Oh, yeah. I'm going to put 3 little bars here. That reminds me that you are a trailing 0 and there was a decimal. What's the total number of sig figs there?
2.
Is this not, that's not bad, is it?
Right.
Next one. Wait, I've already done all 3 of those, haven't I?
Yep.
Oh, then how many is there?
3.
How about this one? Does this have a trailing 0? Does it come after the 1?
Nah.
Wait, trailing means come after a sig fig. Does that 0 come after the 1?
Yep.
Now he's in if there's a decimal somewhere.
Yep.
Oh, yes, there is. So I'm going to put 3 bars here. And what's the total?
4.
All right. Now, they did this on purpose. It's a tricky one. Are these trailing zeros?
Nope.
No,
What? Look at me. Look at me. Are these trailing zeros? Do they come after a significant figure? They don't come after the 5? Wait, do they come after the 5?
Yes.
They are trailing zeros. But trailing zeros only count if what?
Decimal.
And there's no decimal. So you're out. So how many here?
1.
Now you know what that means? What kind of ruler was that? Here's what it was. Ready? It was 0 and 10,000. And you said, 5,000? What do you think? Good ruler? Expensive ruler? Or terrible? Terrible ruler. Now, if I was a scientist, I wouldn't want you to think that I was trying to lie to you. If I had a bad ruler, I didn't want you to think I had a really good one. So here's what I would do. I would write it in scientific notation. Now, how many sig figs right there? How many? That's what I'm trying to tell you. I don't want you to be confused thinking I had a real expensive ruler here. I didn't. So then by writing in scientific notation, I only look at this part of the number. It's only got 1. That's easy. Let's do the next one. Are these trailing zeros?
Yes.
Is there a decimal?
Yes.
Then they're in. So how many? Now again, I don't want you to think, hey, I had a very expensive instrument here, and I don't want you thinking I had a bad ruler. So what would a scientist write this as? Make me proud of you, even though you had a PSAT today. Make me proud of you. Who thinks they know? What would a scientist write here to make sure you know I had an expensive instrument? Yes.
5,000.
No, scientific notation.
Oh.
Raise your hand if you know. You want to try it again?
Yeah.
All right, go ahead.
5 times 10 to the third.
What? 5 times 10 to the third? That's what I wrote down here. That's a bad ruler. Do you have a bad ruler here? Or expensive ruler?
Bad.
No, this is an expensive ruler. You have how many sig figs you get? So I don't want to fool you. So what do I put? Who knows? You want to try it? J3? Yes. Go ahead. Real loud. Say point. Say 5 point. Yes. Yes. If I say 5.000 times 10 to the third, how many significant figures are in 5.000?
4.
4. That was an expensive ruler you had. Is that right?
Yeah.
All right, next
I
one.
get it now.
Do we have any trailing zeros?
Yes.
Yeah.
They come after the 1, don't they? Is there a decimal?
Yeah.
Then they're in. All right, how many?
6.
Woo! That costs a lot of money. That costs a lot of money for that thing. Okay, next one. Any trailing zeros? I've already done rule 1. I've already done rule 2, and there are no trailing zeros. I'm done. Next one. Trailing zeros or not? No or yes? Wait, What is this guy here? Doesn't he come after the 2? Does he count or not? Wait, is this a trailing 0? Does it come after a sig fig?
Yes.
Then he might be in. Now he'll be in. Trailing zeros count if there's a what?
Decimal.
And there is a decimal. Is he in? Yes, he's in. So how many? Okay, and the last one? Hey, I've already marked them all, haven't I?
Yep.
There's no trailing zeros. All right, so what's this one?
5.
Now all I'm asking you to do is, was that bad? Was that a bad lesson?
Yeah, that was good.
Now, I believe by taking out the rules that tell you when you're not in, you don't have to worry about them. You get it?
Yeah.
All right, so let's try it. Let's see. Here's what I'd like you to do here, all right? I'd like you to write these numbers in scientific notation with the right number of significant figures, okay? All right, let's try it. We'll go around the room, and you want to start? Hey, you want to start? All right, now, you have to look carefully. Rule number 1, watch. Rule number 1. Rule number 2, Oreo. Rule number 3, wait. It's a trailing 0, but no decimal, Hayden. So now, give me this, and let's pretend these all had units after them, but give this to me in scientific notation with the correct number of sig figs. A bit louder.
8.04.
Do you put another 0 or not? Was he one of the significant figures? No, he's not. You're not going to show him then. 8.04 what?
Okay.
To the
Third.
positive 3 or negative 3?
Positive.
He's a big number, isn't he? What do you think about that? How many sig figs in this thing right here? 3. How many here? 3. Let's try it again. Charlotte, you're next. Charlotte, rule number 1 says this 3 is in, isn't he? Rule number 2, we don't have any Oreo zeros. Do we have any Oreo zeros here trapped between 2 wafers? There's no Oreo zeros. Are there any trailing zeros, Charlotte? Will they count or not? Is there a decimal? So they count, right? All right, now you know there's going to be 3 sig figs. I'm ready to go. Ready to go.
3.0
Yes, you have to have 3 sig figs, don't you?
times 10 to the -2
Say it again.
times 10
Neg-
to the -2.
2? 2? All right, negative 2? Is that what you said?
Yes.
That's correct. Are you ready?
Sure.
Aiden, you can do it. Aiden, look at these. All of them. None of them are zeros. So how many sig figs are you going to have? 4. Okay, now give this to me in scientific notation with 4 sig figs.
6.995 times 10 to the second.
I am really proud of you. I don't care if you make a mistake here, but I am amazed at all 3. You got no pressure, no pressure. But I'm okay. Luke, I'm okay if you miss it. But you can say, you know what? I never understood rule number 1 or rule number 2 or something like that. Okay. So anyway, see this one? It's already in scientific notation, but oh man, it's already in scientific notation, isn't it?
Yeah.
So can you tell me how many sig figs are in this number?
Just
How many?
1.
Okay, this right here. Now, rule number 1 says, he is right. Now, there are no Oreo zeros, but what about these? Do these come after the 2?
Yeah, decimals.
And there is a decimal, so do they count or not? So how many sig figs are in this number? Since they already had it in scientific notation, I had to just on the other one, okay? All right, Rachel, you're next. What do you think, Rachel? Tell me about the 9s. Is he in or not?
Yes.
How about the 1? How about this 0 right here?
Yes.
How about these? Are they trailing zeros?
Yeah.
Do they count? Yeah, there's a decimal. All right, now write this in scientific notation with the right number of sig figs.
9.0.
And you can't lose any numbers, okay? 9.01. But do I write anything else? I can't hear you. But how many sig figs did you say we had? You said there were 5 sig figs. Right now, you only have 3. Yes. Ten to the what? It would have been if this number had been bigger than 1, but it's a decimal number, so what is this exponent going to be? -1. What do you think? This is where you make mistakes. This is where you learn from your mistake. Everybody got it? All right. Are you ready? Okay. What about this? Oh, this is a hard one. I'm glad you had the hard one. All right. What do you think? What about the 9s? Ian?
Yes.
How about the 1?
Yes.
How about the 0 right here? How about these 2 zeros? Everybody look out here. Look up here. They are trailing zeros.
But there's no decimal.
That's right. So you got to give it to me with only 3 sig figs in scientific notation. All right, go.
9.01 times 10 to the second.
Now you got to be careful because this is 90,000.
Oh, just 4.
Yes. The original decimal point was way down here, wasn't it? Wasn't it? Okay, ready? All right, Taylor. This one's already in scientific notation, so you have to tell me how many sig figs it has.
2.
That was easy. I'm sorry I gave you an easy one, but that's the way it came out. 2 sig figs, right? That was the easy one. All right. You're next. Uh-oh. Uh-oh. It's a hard one. What do you think about the 1? Is he in? Is it the 1 in? How about the 8? How about this 0 right here? How about these zeros? They're trailing. And there is a decimal. Whoa. Whoa. All right, here we go. You got to give it to me in scientific notation with 1, 2, 3, 4, 5, 6, 7, 8 sig figs. This is a very, very expensive instrument. Very expensive. All right, go ahead. I'll be a little louder, sorry. Well, when you put a number in a scientific notation, it has to be between 1 and 10, not counting 10. So I know it's going to be 1 point. Go ahead. Yeah, have them all, right? Now, because you have to have all these. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, yeah. Times 10 to the what? How many? Let's try it again. Ready? 1, 2, 3, 4, 5, 6. You only had to go 7. You only had to go 7 to get 1 point something, didn't you? Now my question to you is it going to be 7 or -7? Make it easy. Make it easy, okay? Is this a big number? It's big, isn't it? Then what kind of exponent is it going to have? See? Let's make it easy. All right, J3, yes?
Why can't you do, instead of 1.08, 10.8?
Okay, no, because the first part of the number has to be between 1 and 10, not counting 10. You can go all the way to 9.99999, but it has to be a number between 1 and 10. And you had 10.8, right? 10.8 is not between 1 and 10. That's an excellent question. Do you hear that question you had? That's why you can't put 10.8. All right, J3, your turn. This is already in scientific notation. Just tell me how many sig figs in.
3.
Yes. Now, you are so good at asking questions. Sean's going to do the last one.
Yes.
Because he, you know why? He didn't think he was going to do one, so I'm going to make Sean do it. All right, Sean, go ahead. Sean, what about that 4? You think that 4's in? Hey, what do you think? 4?
Yeah.
All right, how about the 1?
Yes.
How about the 0 that comes after the 1?
Yes.
Are you sure?
Yes.
Is it a trailing 0?
Yes.
Is there a decimal?
Yes.
Okay, he's in. Well, wait now. Here's the hard part. How about these? Are they in?
No,
Why not?
because they're not behind
They're not trailing zeros, are they? So they're not rule 1, they're not rule 2, they're not rule 3. Is that correct? Wait, frozen. Every time it times out, it freezes. All right, Sean, show everybody in here that you can do, no help, nobody's gonna help you.
Okay.
I bet I have 3 sig figs when you get done.
It's gonna be 4.10 and 10 to the -4 decimal over.
And you sure it's negative? Are you sure?
Yes.
Because it's a little number, isn't it? What do you think? Very, very, very good. All right. So I'm gonna stop here.